Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video, I'm going to summarize the topic, the second topic, which is atomic structure. So the topic is atomic structure. So what you supposed to know in this topic? First, in this topic, we are going to learn about an atom. Because the topic also atomic structure kan, it is the nucleus of the atom, and the nucleus is surrounded by the electron, and this is the number of shell can be occupied by the electron. So as we know, this is the nucleus composed of proton and neutron, while it is surrounded by the electron. This model actually proposed by Niels Bohr. That's why we call it as a Bohr atomic model. Alright, so what you're supposed to know when for this part is you're supposed to know about 3 postulates of atom proposed by Bohr. So what is the first postulate? According to Bohr, the first postulate is electron move around the nucleus in a circular motion. While orbiting the nucleus, the electron does not absorb or radiate energy. That is the first postulate. The second postulate is, as we know, when the electron moves around the nucleus, it required certain amount of energy. That amount of energy is called the energy was quantized. The third one is when an electron at the ordinary condition absorb an energy, it will excite to the higher energy level. Right? So electron is absorbed when the electron is absorbed, it will excite to the higher energy level. And when electron is emitted, means it is transit from higher energy level to the lower energy level. So this is the first 3 postulates that you're supposed to understand. And then when we cut this part, we can see as an energy level, where this is the first energy level, this is the second energy level, this is the third energy level, this is fourth, and so on. The distance between each energy level is different. It becomes closer when it's far apart from the nucleus. Right, so this is what we call an energy level. So this is the lowest energy level, which is n equal to 1. We call it as a ground state. The others, we call it as an excited state. Right. So let's say when we have an electron at a ground state, when it's absorbed the energy, it will excite to the higher energy level. So the process involved is absorb energy. So now the electron is already at the higher energy level. At the higher energy level, the electron was unstable. So what happened to the electron? It will fall back to the lower energy level. It can be fall to n equal to 2, to n equal to 3, or n equal to 1. If it fall to n equal to 2, it's still unstable, then it will fall back to n equal to 1. Same goes to when it's fall to n equal to 3, it will fall to 2 and it's still unstable, then finally it will fall to n equal to 1. So this spectrum, this situation will produce a line spectrum. So we can illustrate the line spectrum like this. Let's say this is the line spectrum for Lyman series. Maybe this is the first energy level. maybe this is the first line in the Lyman series, this is the second line in Lyman series, this is the third line in Lyman series, fourth, and so on. Right? Okay, so next we will look at the how we can interpret, or how we we will look at the formula involved in this topic. So the first one, since the energy was quantized when the electron moved around the nucleus, let's say this is our nucleus and we have an electron here. So this is an electron at n equal to 2 and this is an electron at n equal to 1. So how to calculate the energy at each energy level? So let's say if you want to calculate the energy at n equal to 1, the formula is E, which is the energy, is equal to negative RH 1 over n squared. N represent the energy level, right? So the value is 2.18 10 to the power of negative 18 joule, 1 over 1 squared. So negative 2.18 10 to the power of negative 18 joule. This is the amount of energy for electron to move around n equal to 1. Right? So this is the energy at specific energy level, where we call it as the energy was quantized. Okay, this is the first formula that you're supposed to remember. We apply this when it does not involve any electron transition. The second formula is how much energy produced or released when an electron moves from one energy level to another energy level. So for that, we will use the Redbird equation, which is, it is for transition, energy for transition. Delta E, which is changes in energy, RH 1 over n initial squared, 1 over n final squared. In this case, we use initial and final because the energy can be absorbed when the initial is lower than final, and the energy is released when the initial is higher than the final. So in this case, let's say we want to calculate the energy for the transition between n equal to 2 to n equal to 1. Based on this statement, we know that it's supposed to be emitted. So we can apply 2.18. The initial is 2 and the final is it fall to n equal to 1. And you will get the answer . Negative 1.634 10 to the power of negative 18 joule. Why the value is negative? It's indicate that energy was released. So this is the second formula that you're supposed to remember. The second formula is applicable when it's involved the transition of the electron. The first formula, you can use it when you want to calculate the energy at specific energy level. You have to differentiate between it. So the second formula is called a Redbird equation. Then we will look at the third formula that's involve energy, where delta E is equal to hc over lambda. C is our speed of light. H is a Planck constant. It is already given in the question. And lambda is the wavelength. So normally we apply this formula when we want to calculate the lambda value, or we want to determine the energy and we don't know the transition. And also the derivative from this formula is frequency is equal to C over lambda. This is another formula. So from there, you can write this formula in a form of delta E, delta E is equal to H frequency. Alright? Okay, now we want to determine the wavelength. So the fourth formula is formula that involve the wavelength. So number 4 is 1 over lambda, which RH 1 over N1 squared minus 1 over N2 squared, where N1 should be less than N2. This is the fourth formula that you're supposed to remember. Normally, we use this formula when we want to determine the wavelength where we have the transition of the electron. Alright, so in this case, we use the value of RH 1.097 10 to the power of 7. Let's say we want to determine the lambda for the transition between n equal to 2 to n equal to 1. So according to the formula, n1 should be less than n2. So we took 1 squared minus 1 over 2 squared. So the value will become 1 over lambda equal to 8.227 10 to the power of 6. So lambda is 1 divided by the answer become 1.215 10 to the power of negative 7 meter. See, normally we give the lambda in nanometer. So how to convert this value to nanometer? So we can shift 1, 2. So the answer will become 1 to 1.5 this one time nanometer, because normally lambda is given in nanometer. So if you can see, we have two different types of Redbird constant value. The first one is 2.18 10 to the power of negative 18, and this is the second value. So what is the difference between is? Alright, so we will use the Redbird constant 2.18 10 to the power of negative 18 joule if we use the formula delta E atau E for energy, negative RH 1 over N squared, or RH 1 over N initial squared 1 over N final squared. We use the Redbird value 1.097 10 to the power of 7 meter if we use a formula 1 over lambda. So hopefully you are able to differentiate between these two values. It is according to the problem that you want to solve. If you want to determine the energy, you're supposed to use 2.18. If you want to determine the lambda, you're supposed to use this value. So this is the summarize of the whole of one part in atomic structure. So hopefully this will help you to solve the problem related to atomic structure. So that's all for this video. Thank you very much.